Alright, Mr. 729 Invader. We finally got this thing done for you, brother. Basically, just a quick recap. This is a box that I did a little metamorphosis type transformation I like to do with these boomers slash Palomars for him one time, and he used it for a little while. I think he had some power supply issues or something, and he blew a few of the 1446s here. I need to still go through and do the gain check on all them. But anyway, he's like, I'm just ready for an upgrade. He's like, I want a little bit more output, etc., etc. So I was like, well, hey, let's just go ahead and upgrade this thing and retrofit it into a HG2879, since we're going to have these for a long time from here on out for you to use for replacements and everything. So I knew to do this that I was going to have to take this board out and really do some changing around, remove a lot of components. I went ahead and removed the fake bias that's in there. It's just sitting in there doing nothing. That's how all these boxes are. And I had to clean up a couple of things. But the main thing I really needed to do is I needed to draw myself a schematic on how the RF travels from the relay to the input section, because it does get kind of cluttered in here on how they have the attenuation. Because honestly, the boomer slash Palomar 600s, they're backing down that driver 1446 dramatically. I mean, my honest opinion, it's best just to eliminate it and have a mild, medium type high drive 4-pill and hit it with a decent radio, because they're backing the 1446 down like crazy. I'll show you what I'm talking about here. Actually, I need to write down these values that I didn't write down until I removed the resistors here. These are 6.8 ohm resistors. Just use them as a little buffer resistor. Alright. This is for reference if anybody else is wanting to do something like this. Because I knew once I did this and used the HG2879 as a driver, I needed to completely redo the input section to this, because I didn't need all this attenuation, because these are bigger transistors and they need more drive. So they're using a 1600 puff picofarad coupling capacitor, which they also do on the output. Really no reason for that on these amps, but that's just what their design is. And it comes up to here at this junction point right here. And then you've got a 68 picofarad capacitor to ground, which is the beginning of the partial input tune for the input of the driver section, and they trim out the rest of it right here. It goes through this buffer, what I like to call buffer resistors, the small 6.8 ohm resistor. Then they got a 27 ohm to ground, which is really pushing that RF and shunting it to ground. That is a very low resistor, which is the same one they're using over here for the medium. Alright, I did this backwards. That's low, that's medium, so I put that on there backwards. But anyway, so at that point, it comes to this junction point right here. You've got a little shunt for attenuation. Okay. Then from this point, it goes to another little buffer resistor, and you're doing the rest of the trimming there for the input tune. And you've got a wire that goes to here for here, and these are going to put these resistors for lower, medium to ground, or high. It's going to be not connected to any of the resistors. Then it comes on to the input there. So basically what I did is I eliminated all of this. I eliminated everything. The resistors, the caps, everything. And what I did is, instead of 6.8, I put a 10 ohm. 10 ohm. I usually do all 2879 like that. I usually put like a 10 or a 22 ohm resistor right there, just for a little bit of attenuation to back it down. And then I went ahead and dealt with the tune right here at one place. That's all I needed to do anyway, since I went ahead and used my trimmers here and had 4 trimmers in here. I went ahead and tuned it out. So there you can see that. This first 10 ohm comes from that junction point right there onto that pad, carries on to here. There's your input tune right there, and then there's your wire that goes to there, and then up under the board is where it's going to the input winding. Next, what I had to do is I had to unwrap all of these transformers. The windings had to change completely on every one. I'm not even going to try to remember how the driver section was. I remember these were 4 and 4, which goes with a 1446 or Motorola type transistor. So I took these off, went ahead and wrapped that with a 5, and I think maybe this had 3, and I rewrapped that for 2. Okay, and all of these little power upgrades I already had done from before. So I went ahead and they also had a 10 ohm resistor that went from this side to there for a little bit more attenuation. I didn't put that in this schematic because it's on the transformer side of things, so I went ahead and took that out too. Didn't need any of that. And then here's our compensation capacitors right there and right there to make up for the other transistor not being in this section. So then what I went ahead and did to incorporate all this is I put a little pad down here so that I could have the output tune for the driver section right here, and then this right here is the input tune for the 4-pil section, and then that's the resistor that connects the two, a little buffer resistor going to the input splitter. And that also helped me incorporate this input splitter as well. So there's your input splitter. So these are the old input splitters. We went from a high wrap 5 and 5 to a low wrap 2 and 2. Okay. And there's your 4 HGs. Took the little VK-200 whatever that was sending the fake bias. Put all new 120s that were matched. There's your rewraps for the 3 and 3 on the output transformer. Here's your new combiner. Incorporate that with a wire going down there. Big $5 cap from ICA for the output tune. One of your fans wasn't working. I had to go ahead and fix that. And I went ahead and put 2 new 330s on the input transformers, which is that's what's down there. And there's your chokes. Okay, and they had just a regular little bead choke or whatever on the other one. So put your new 1000 there, put your new 120 there to ground, put your all new 10 ohm resistors on everything, little quarter watts, and use the same feedbacks that was on there before. So yeah, man, we had to do a whole retrofit to this thing, man. Had to clean it up a lot on the undersides, clean up some of the solder that was on the underside. And this thing now is a banging 5-pil for you. Alright, here's the deal. I still have not got myself a good high amperage regulated supply yet. It's coming. I just ain't got to building it yet. I've got this, which, as all 5-pils do, threw this into protection. This is only like a 75 amp power supply, but it goes into protection like around 50 or 60 amps. So I've got a 100 amp supply over here, but the problem is that's at 12.4 volts. You know, the volts are too low. So we're going to hit this with the unregulated 100 amp supply, which I hate doing with HGs. So what we're going to do is just burp it quick. I'm not going to stay on the mall long or anything like that. We're just going to burp it quick to show the output. And I've got it on the medium tap right now, and I already see that it's bringing it down to 13.4 volts, I believe it was. So we need to go to the high tap, but I'm just going to show it on the medium tap first. And by the way, I'm on my bench radio, which is barely even doing 3 watts. It's doing like in between 3 and 2.5 watts. So it's not a power monster by no means. It's not the old 4-watt radio I was running. It's a newer radio. So let me show you what this bad boy's going to do, man. We got it on high. Okay. And by the way, the high, low, medium works great. The way they had it done before, when you would go to medium, the input reflect would come up. When you go to low, the input reflect would come up even higher, because it's just, they didn't have the inductance with all the capacitors done just right. And that's just the way it worked. But now it stays good and low, and that's how you want it. All right. 1,000-watt slug for the peak. RMS, that's the 5-watt slug for the input there. So like I said, we're just gonna do some quick burps here. Do. It's right there about 700 watts PEP. Do. About 250 watts RMS. Input. Do. Yeah. Beautiful. Absolutely beautiful. And like I said, the voltage is coming down very low. So we're going to go over here and flip it on the high tap and give this thing all the current that it wants, but we're just going to burp it. Quick. All right. PEP. About 850, almost 900 watts. Right there about 300. Beautiful. Go ahead and turn this thing off. The switch is hard to get to. So this thing is working great, man. That's usually what a 5-pill is going to do, hitting it with that little small radio. The thing's only doing about 2.5 watts RMS. That 2.5 watts is converting into about 300 bird. Hit it with a little bit bigger radio, because, you know, don't forget, I do have two 10-ohm resistors right here. And theoretically, yes, you could jumper this to here and jumper this to here and have no attenuation, but it's good to have a little bit of padding. You know what I'm saying? It doesn't hurt to have a little bit of padding to knock that RF, but put a little bit of stronger radio in here, you're going to be hitting 1,000 watts, brother. You're going to be hitting 400 bird. I personally, if you want this amp to last you a long time, I personally, this is just personally, because as time has went on, I ain't a hothead box runner, I guess, whatever you're gonna say, as I used to be, driving the piss out of these things. I don't do that like I used to anymore. I think that taste got out of my mouth, and when Toshiba started costing so much, and yeah, these are you know, are not that expensive, but still, I kind of got in the habit of running boxes a lot easier. But I wouldn't run it like that. 700-800 watts is beautiful, beautiful. If you really want it to last you a long time, run it about 600. Like I said, these high and lows, they work great. Use them. Use them. This is your box, bud. I hope this bad boy lasts you a long time. And I'm not going to turn the fan on right now since I'm on the unregulated supply. But they are now working. This one right here was out. One of the wires had came undone for some reason. So I went ahead and fixed that for you and got it back wired to the switch for you there. And you know, that right there is just knocking it down a little bit, just in case you run it on around 15 volts, 16 volts, it'll work for you. And I'm glad to get this thing done for you. Thanks for hanging in there with me. I know it took a little time to get this thing done, get to it. Once I finally got to it, it only took about 3 days. That's because I've met me a new lady. Been spending a lot of time with her, so just been kind of working on it in between. But we got her done. So I appreciate it, buddy. 73, hope this thing lasts you from here on out. We'll see you. Bye-bye.